Hello everyone, this is Trista. So at this conference, I'm going to share this topic, especially around how to achieve the availability, scalability, elasticity around your databases infrastructure on Kubernetes. This is something about myself. Actually, my area it's around the databases, especially the distributed database system, cloud databases, and the Kubernetes. So that's why today I choose this topic as my talk. I will talk the DBRE database reliability engineering stuff, and also about your MySQL, PostgreSQL, all the monolithic databases on the Kubernetes. Apart from my job, actually, I'm an open source and I love the open source, so I'm the Apache member incubator mentor to help to give some the tips and suggestions to the open source community and their project. So that's my background. And now I'm the co-founder and CTO of Sophia, this startup company. Sometimes I will post some of the articles about the startup, the open source community project, Apache, and databases and distributed system on my LinkedIn and Twitter. So if you have some questions or you want to talk with me more, please give a look there. So let's get started with today's talk. Today, I will first introduce some of the background about the SRE, SLA, and DBRE, and then we will talk more about your databases on the Kubernetes on the cloud. And I'll give some of the solutions and ideas and architectures about the distributed databases and how to achieve the high availability, scalability, and elasticity around all of them. And if I have more time, I will give the demo. This demo, I do it by myself, but if we have no enough time, I will just give a brief introduction about it. You can just refer to this PDF file and to do it by yourself. Okay, so the background is SRE, SLA, DBRE because it's actually the topic of our conference, right? So I don't want to give much more talk about all of the concept. I just want to say that currently, I know that most of the people will ask that, do I do the career switch or change about my DBA career? I want to say, especially when the big data become the hot topic, and we have more and more popular distributed database system or big data platform comes out. I guess it's a good time to consider about your job, about your DBA, and about your data, all of the stuff. So I think it's necessary to know more about the DBRE and how to use your database experience to provide the good SLA, service level agreement, to your services and to your the companies, especially the application layer, right? But actually, when we consider the SRE or DBRE, I want to say because the database it's different from your application service and all of the stateless services, right? But the databases you need to consider about the the connections data and the persistence data, the data persistent, right? So you need to give more specific consider about your DBRE stuff. But they all share the same, the overlapping area, especially about the SLA, SLO, and SLI. If you want to learn more about all of the ideas, I recommend the following two books. But today, we will just talk about the DBRE's SLA, the indicator, because no matter you are the DBRE, the DBA, or you're the developers, you consider how to, you have the high SLA agreement, right? You commit to your users that you will provide that levels of service agreement, right? The quality. So if we give attention to the DBRE, databases and SLI, that is the service level indicator. We use this indicator to watch or to review that the service quality or the service level agreement is good or not for application or for our end user. Yeah. So this book DBRE, this book gives the good, the SLA for our databases, for example, the latency, the throughput, the availability, the durability, or the efficiency for us to consider about our quality. But it's a high level indicators for our production environment. So I just give them the more practical indicators around our databases and production environment. For example, how to large the tremendous data, how to provide efficient querying answers to our application, and how to do the data security, and do your database cluster have a good elastic scaling capability or not, and what's your backup and recovery, and how to do the metrics to help us to locate the error or exceptions, and if it come out, and how to make our infrastructure become portable. Yeah. And do we have the good automatical, the deployment principles or the method, right? Yeah, so that's the specific items for our databases for us to review or to evaluate the quality of our database service. So I, on the right part, I also give some the technique to solve or to reach that goals. For example, we can use the distributed system. We can do the data sharding to help our database infrastructure have the scalability or elasticity. And also we can consider to create more replicas to do the RAS splitting strategy for our traffic, for our visit, to make this database cluster have the high availability or can have the higher throughput. And also we can use some of the data encryption, the open source project, and to help us to protect our data. We can create the monitor or metric system to help do the learning stuff, right? And also we need to consider use some the Helm or operators, especially on the Kubernetes, to help to provide the out-of-the-box deployment and all the stuff, the maintaining work. So that's the techniques I can give to solve part of the SLI or the items on the left column. Yeah, for our databases, actually, for the end user, actually they don't care about all of the specific indicators or the all of the stuff. They just want to know that the end user, they just want to know that your database service can provide the service when I do every queries. And at the end user, you just want to know that do your databases can provide the efficient querying and to answer my question as soon as possible. So that's the main point your end user concerned. But for our DBRE or databases or developers or DevOps, we need to dive into to consider the following indicators. The next part, I need to give the solution for you to solve all of the issues I mentioned before. I know that most of you will use the PostgreSQL, RDS, MySQL, Oracle SQL Server on your production environment. But now we enter into the new era, right? So we need to consider how to use the new solution to solve the the current the headaches about our databases infrastructure. First, I suggest that you can just use some of the distributed database vendor. Because different databases vendor, they will solve one or a few headaches of your databases. So you can give the details look and do some the research around all of the database vendor to look they can help you solve your headache or not. The second one, we can just consider to use the one-stop solution. You can choose the cloud vendor. They definitely provide some the databases or big data and platform or product for you to solve the current issue. The third one, that's what I want to mention today. I want to give a new idea about your databases architecture, and if you don't want to be locked in a database vendor or the cloud vendor, maybe you need to consider how to make my database infrastructure become like more flexible and portable, the stuff, and how to leverage my current databases infrastructure. Because I know if you don't have the specific requirements about your databases, and you don't want to overturn or change your databases and infrastructure, right? So I want to introduce the third options for you and to help you reach the following benefits from this new solution. The first, this solution can help you leverage your existing databases. Don't do a big change to your MySQL infrastructure or PostgreSQL database infrastructure, and just to leverage them, but can upgrade your current monolithic database infrastructure to become a distributed one. To do the data sharding or data encryption, such good features to make your current monolithic databases become the distributed one. And also, this solution can give you more the necessary the good features around your database infrastructure. For example, the SQL firewall or SQL audit, the traffic governance, or the elasticity capability. And that's part you consider. Do I leverage all my favorite Postgres or Postgres databases on the Kubernetes, right? And also give you some out-of-the-box deployment way to help you quickly do some demo to test it's okay for you or not, right? So that's the benefit from my today's topic. The basic idea comes from the distributed database architecture, because we know that if you want to make a monolithic architecture become a distributed one, that means we need to split a big databases or big project into small one. All of them will be located in different servers or machines, right? So that means the distributed, right? Because such architecture, the new architecture can help us to improve the databases and infrastructure to make it have the skill in, skill out capability or elastic capability, or can help us to manage more and more tremendous data, right? We cannot just rely on one server machine to help us to manage the PB or TB, the data, especially in this new era. Every day, every minute, every hours, or end users or applications create their data, right? So Look at here, we want to adopt the distributed database architecture. That means we split a single one into a lot of small one, make this architecture have the scalability. Basically, when we speak the distributed database system, actually we'll split this single monolithic databases into two important elements. The first one, the computing nodes. The second one, the storage nodes. A storage node will help us to persist your data or do the local compute to get or store the partial data. But for computing node, their capability or their function is to provide the vivid entrance and to do the global computing workflow, right? And to answer the people's question queries. So if you give a look at the MongoDB's architecture or the CockroachDB architecture or other one, you found that they use the same idea to do the distributed one. So we based on this idea, and today I want to leverage your favorite MySQL or PostgreSQL or SQL Server databases and to make it or update it to become a distributed one. So here we can leverage your current databases to make it work or act as the storage nodes, right? Because the PostgreSQL is people has used it in many of the production environment. We trust it, and it's stable as the working as a single databases. And here in this distributed database system, we regard it as one of the storage nodes. It can help us persist your data, do the local computing, and here we just want to import the computing nodes into this distributed system. Therefore, the computing node, the new one, plus your current databases, the PostgreSQL or MySQL databases working as a storage node will merge into a distributed database. Right? So who can be the computing node? That's an open source project. It's the Apache sharding Sophia. If we use Apache sharding Sophia, I will give the brief introduction about it. It's actually a database engine. Or database is a distributed database engine or a distributed database proxy, right? So if you use the sharding Sophia working as the computing nodes, then you can see here the sharding Sophia plus your PostgreSQL database cluster will made up a distributed databases system. So for your application, you just send your queries to this proxy or to this distributed database engine, and sharding Sophia, it can deploy it as a cluster. It can work at the computing nodes of this distributed data system. It can pretend itself as the database server to handle all of the queries from our application. And this proxy can help us to shard our databases or shard our data. It can do the rewrite, splitting, traffic governance strategy. That means it's like the database gateway. You just send your queries to the sharding Sophia, and sharding Sophia will find, this query, we can send it to one shard, right? We can send it to the replica one, right? So sharding Sophia can help you do the data sharding and rewrite splitting. And also, if one of your Postgres crashed, it can be aware of that status and update itself. Therefore, your application, next time your application will visit this database proxy, sharding Sophia will never send this query to your crashed instance. The crashed replica, right? So you just to tell Sharding Sophia that you want such of the features, and Sharding Sophia will work as the distributed computing nodes or the database server to handle all of the queries, and also can help you handle the visit or the traffic governance, right? Yeah, so that's the magic or the function of the Sharding Sophia. So when you use Sharding Sophia, and your infrastructure, database infrastructure, will from this one become this one. So before, your application just directly visit your PostgreSQL instance, your application needed to know it's the primary node, it's the replica node. But later on, if you use Sharding Sophia, you don't need to care about all of the replica one or primary one. It's the first shard cluster, it's the second shard cluster. You don't care about all of the stuff. Sharding Sophia help you do all the stuff. You just send your query to Sharding Sophia. Sharding Sophia will deal with all of the requirements. Yeah. Therefore, it's the function, and I just want to introduce it to and tell you how to use it in your database infrastructure. And second one, let's give a brief look at its GitHub statistic, because nobody want to use the new project because you worry about that, and maybe one day this project disappeared, or a closed sourced become closed sourced, right? You don't worry about that. It's has been open source for 6 years, and it's the Apache top level project, and it's already received more than 400 contributors, and we have nearly 18K stars on the GitHub, and already released more than near 50 times, right? So it's a big community. It's a very popular open source project, and their document and the user cases are so good, a good quality for you to use it or to know more about it. Okay, so the Sharding Sophia clients, as I said before, at this page in your application, just use the databases proxy to visit your databases. And actually, for this database proxy, Sharding Sophia provides 2 clients for you to choose. First one is the driver client. The second one it's the proxy client. So you can base your cases to choose one of them. For Sharding Sophia, for this driver, it named Sharding Sophia JDBC. It's just suited for your Java application, because you can see its name, Sharding Sophia JDBC. It's a lightweight implement of your JDBC interface. So you just use this lightweight driver, and this lightweight driver will help you manage your database cluster and do the data sharding or the rewrite splitting or data encryption, such features. And also for your Golang or Rust or other development language application, you can choose the Sharding Sophia proxy. Actually, you need to deploy Sharding Sophia independently. It will really work as a database server. It can also share the same features with the Sharding Sophia JDBC, like shard your data, do the data migration, and do the rewrite splitting, and help you do the data encryption, data masking, SQL audit, all of the good features. Yeah. And so here you can see this page. It's index of all of the features and all of the databases this project supports. But I know you will consider how to make this Sharding Sophia to work with such features. And the next part, I will introduce the distributed SQL. It can help you do the configuration stuff. Yeah. So the next part, I need to introduce the out-of-the-box in deployment, especially on Kubernetes. Sharding Sophia on cloud, this repo here, it can help you quickly deploy Sharding Sophia proxy on the Kubernetes. One command to deploy every elements of this project. And it can also help you deploy the governance center or proxy or your databases. And currently we support the PostgreSQL databases here. So it's actually it provides the Helm charts and operators to guarantee the high availability and automatic deployment and the metrics such features on the Kubernetes. So our demo, I will use this repo, Sharding Sophia on cloud, to help us quickly deploy a Sharding Sophia cluster, and you can choose and use the RDS working at the storage node, and just like Sharding Sophia on cloud repo to help you deploy the Sharding Sophia proxies, right? Because like I said, this one benefit of this solution that you don't be locked in one cloud. Because here you just use this open source project to working as a computing node of this distributed databases, and it can reach the same qualities as the distributed system. For example, data sharing, distributed transaction, right? Another benefit of the solution that your storage node or your databases can be located anywhere. It could be the RDS on Google Cloud or AWS. It can be the open source databases working on your Kubernetes cluster. If you use the PostgreSQL operator or PostgreSQL Helm charts, you can just deploy your databases on Kubernetes, right? Yeah, so no matter your database is located in where, right? Where your database is located, and Sharding Sophia, just like Sharding Sophia visit your storage node, then your application just visit this virtual distributed databases server. Then you can own this distributed database system. So that's the flexibility of this solution. So here, in my demo, I just choose one popular PostgreSQL chart to help me to deploy PostgreSQL instance on Kubernetes. Actually, you can just use your current RDS service. And I use the Sharding Sophia on cloud repo to deploy the Sharding Sophia cluster. Then application just visit your Sharding Sophia proxy, Sharding Sophia cluster. Sharding Sophia cluster can help you do the data sharing and the rewrite splitting features. So you can see here, use this repo to deploy all the stuff. And I want to say here, like I mentioned before, how to create a sharding table. Here, I want to introduce the distributed SQL like this one. Create a sharding table user. This user, the sharding column of this distributed table, its user ID. And we use the mod sharding algorithm to split this logic table, single table, into 4 shards or into 4 actual table. All of the 4 table will be located in the first PostgreSQL group and the second PostgreSQL group. PostgreSQL cluster. So you can see here, it's just a SQL dialect right, of our PostgreSQL SQL or MySQL SQL or Oracle SQL. It's just a SQL, but it's different from your standard SQL language. It's a new type. We name it as the distributed SQL language to help us to create your sharding database architecture. That means you just deploy your PostgreSQL databases and sharding Sophia proxy, and you ran all of the distributed SQL at sharding Sophia proxy client, at sharding Sophia proxy. Then it will help you automatically do the data sharding, right? So that I mentioned before. If you want to the sharding Sophia to help you do the data sharding or skew in, skew out, or read-write splitting, or the SQL audit, you can just use the distributed SQL here and tell him use the distribute SQL, and it will help you reach the work with all of the functions I mentioned before. See here, the read-write splitting function. We can just tell sharding Sophia, hey, this one is the write data source. This one is the read data source. And we want to use the random strategy to help our application to send to do the read-write splitting, that function, right? So it will randomly send your query to the different replicas. For example, if you have the 3 replica, right, all of them can help you get the readout. And here we use this distribute SQL to tell sharding Sophia, hey, you can randomly send the user's select queries to different the 3 replicas. So that's the power of the distributed SQL. This demo, I use a lot of the distributed SQL to help us manage our database cluster and to do querying and gather readouts from this distributed system. And if you have time, you can do it by yourself to do the demonstration. That's all about today's talk. And if you have any questions, you can contact me here, or you can just raise the issue at the GitHub. I mean, the community are willing to answer your question and to help you out. Yeah, see you next time. Bye.